And just a reminder, the way this is going to work is ideally you're presenting off a laptop, from your own team. You guys bring something up, present off that, send me your slides, but you'll be using your own laptop to present. What we have up here, we have a VGA connector. We also have an adapter to go from Thunderbolt to VGA. So if you need something other than that, check around your team, see if you can meet that need. If not, let me know. We'll figure out something else and an alternative laptop for you to present from. And again, just a reminder, here's the list that we're going to go through. And for those of you who may have stepped out, we'll do 4 minutes per presentation. And remember, your audience, primarily your audience is those of us here in the room. So yeah, we have a technical background, but don't necessarily work in the working group that you're working in. So if you can help us understand and maybe answer these questions, what you're trying to solve, how you plan to solve it, how it actually went, and then throw in a few highlights that you think are significant. That'll be great. Feeding back results into the working group is a big thing for us here because that's really the goal, right? It's not just for you to do something great over the weekend, which is cool, but we also want you to help move the whole work of the working group forward. So let us know those types of things too. Okay. And with that, I think I'll hand it over to the WebRTC team and let them share with you what they did. You guys want my adapter?
Oh, we have one. We have one, or we can use yours. It's the same.
Okay. All right. Thank you. It's on yours.
Okay. Hi everyone. So this weekend we worked on a WebRTC piece app. Actually, our team at IIT, we built this system which is able to get our indoor location information. However, we are using an EasyNet which allows us to get only SIP call. And we receive this SIP call on a SIP interface, which is a piece app. So what we wanted to do this weekend is to do a WebRTC piece app module, which is able to take SIP call and transmit them to a WebRTC piece app, which is able to show you the indoor location of the caller. So that's the architecture of the WebRTC piece app module. So you can see the SIP caller over there, which is using an indoor location application on Android. It's sending a SIP call through a proxy, and the proxy does the translation to do the transport over WebSocket. Then on the browser, we handle this call. And on the other part, we can have a web caller too, which is able to make a call. And the web piece app will handle this call too, which is a pure WebRTC to WebRTC call. So this weekend work was to build a WebRTC call taker, which is able to handle a SIP over WebSocket call. For this point, we just have an issue with RTP media. And the second point was to handle WebRTC call. Third one was to display the caller indoor location information. And the last one was to display the geolocation information provided by the browser using Google API. So now we will do some demo. So the first one, Nicolas will call me, and we will do a web browser, a browser-to-browser call, and we'll try to get his location. So, okay, we received the call. As you can see, you can have the latitude and the longitude printed there, and you can show on the map where it is. And it's here. But it's not, no, it's not really, not this time. It's not really accurate because it depends on the previous IP address. So now we will make the SIP call. So, we do the SIP call. Bharat over there, we make a SIP call using the indoor application, and now we will get the indoor location information. So as you can see, we received the SIP call. So Bharat is near the coffee table because we have one icon placed on the table over there. And now he will try to make a call on the t-shirt table.
Right under the t-shirt table.
And as I said, we have still a problem to handle the media through this way. So for the last demo, Bharat. So to explain, we have one icon on the t-shirt table, one on the coffee table. Normally, it should print the. Thank you. Welcome.
Hi, everybody. My name is William Dennis. I've been working in the OAuth work group. In particular, I've been working on this draft OAuth for native apps. So the thing we're working on this weekend was the AppAuth library. This is a library that implements the following specifications, including the BCP that I'm authoring. It's actually an open source library, so you can download it if you like. And I must say, like, echoing some of the sentiment of this hackathon, I've noticed that by creating an open source library along with the specification, we're actually seeing like wider adoption of the specification. So I'm definitely a big advocate of kind of more open source implementations of our specifications. I think this is a really good trend. So the OpenIE Foundation actually has this free relying party test infrastructure that can actually test some of these protocols that AppAuth supports. It's available at that link. So the goal for the hackathon was to run those conformance tests, fix any issues that came up. We also had two stretch goals. The first was to create an automated test suite that can just run through all those conformance tests anytime we like. And the second stretch goal is to actually submit the test results to get a formal certification by the foundation. So in terms of the achievements, we got the JWT ID token passing implemented. We are theoretically passing the code, dynamic, and configuration tests if you exclude some WebFinger use cases. And the test harness, that was one of the stretch goals, has been created, but it's not fully configured yet to run through all the tests. So some of the follow-up work is going to be fleshing out that test suite, adding more of the tests in, and then finally submitting those results. So yeah, that's what we did. And yeah, thanks for the space and the
Where's that display thing? Yeah. I'm trying to mirror it, but I don't see both. Shall I just try to? All right. Yeah, that should do the trick. That's the wrong one. Right. Okay, PERC is a group about double encryption to enhance the security and the privacy for the media online, right? So the problem we have in some of the technology, so it's applied to SIP and WebRTC, is that whether in the case of WebRTC you encrypted end-to-end, but originally you P2P. If you start putting a media server in the middle, then you only encrypted hop by hop, which means the media server is going to decrypt, and anybody that compromised the media server can listen to what you say and see what you see. So the idea here was to add another layer of encryption on top of that, a real end-to-end layer of encryption for the case where you would want to use SIP of WebRTC media or whatever else. PERC is not specific to a stack with a media server in the middle. So a usual non-encrypted RTP packet looks like that. You have the header, the payload header, and then the media. Of course, I'm picking the wrong presentation, so it doesn't work. If you had encryption around that, what happened is the RTP header is still in clear because you need it to be able to route the packet and know what you're dealing with, but the media itself is encrypted. And then you have a signature on the bottom that allows you to see on the receiving end if an encrypted header was tampered with. So the media is encrypted, and then you have a way to tell if somebody changed an encrypted part. So in the media server, wrong presentation again. So this is what happened in the life along the path, right? You send an encrypted packet. The media server has access to the key, so you go back to a non-encrypted packet, and then it's going to read information on the media payload description to be able to route the packet, right? It sometimes duplicate it if it's an SFU, another mixer, right? Create a new stream and send it to all the participants. No, let's try to click on the right place this time, right? No, if you had a PERC packet, you do that encryption twice. So you end up with something like that. You have an end-to-end key that the media server doesn't have access to, and you have a hop-by-hop key the media server has access to. So on the media server, when you decrypt, the problem is since there's two encryption, you don't have access to the information you need to be able to route the packet. So most of the PERC draft right now deals about what information, what is the minimum set of information we need to bring from the encrypted part to the unencrypted part to be able to route the packet and have the media server do their work correctly, right? So the idea is to use the RTP header extension mechanism to bring the information we need from the part that will be encrypted to the part that will not. There's mainly two, and you need to do the same thing on the media bridge, since the media bridge now need to know that he can find that information in the media extension and not in the place he was used to find it before. So I work on the client part on the modified libWebRTC and modified Chrome to add the extension, the OBS and the frame marking and things like that. And the Atlassian team work on the Jitsi bridge to be able to have the complete path to test that. This weekend, I work mainly on porting the code to Chrome 57 for the RTP extension. All right, here we are. quickly, I took all the code that was based on Chrome 55 and bringing to 57 that has a new RTP packet extension management system. Niels and Adam Roach from Mozilla are doing that for Firefox. I'm doing that for Chrome. GT is doing that on the SFU part. And there is one or two SFU. Janus is interested, but they're busy with the IETF right now. So we 4 or 5. The working group is 10 people active. And in Seoul last time was the call for implementation. So that will be the first. We're presenting those results Wednesday.
Yeah. How big is it?
Just two seconds. Plus the.
Alan, John, how big is your team back there? The WebRTC team? Yes. How big? How many people? 5 students.
Okay, so we're looking at some of the message-based security things that we are needing for CoAP. So this CoAP basically right now is based solely on hop-to-hop security. We did an interop with a person here and a person in Austria on the OSCOP message spec, and we fed back 2 things that absolutely had to get fixed. And we've had a number of other things which are not either fully documented or we'd like to see fixed. We also did some work on EdHoc, which is a protocol in the ACE working group for doing establishment of security contexts, given a set of pre-shared secrets or a common set of known asymmetric keys. And that actually got finished, but we don't have any interop tests running on that yet. In addition to that, we had 3 people who showed up who did some work on the Java publicly available COSI implementation, which underlies both the EdHoc and the OSCOP specs as part of that system. And one of them got finished with that piece of work. One of them is still in process, which is moving the Java library from being hard-coded dependent on Bouncy Castle to using the standard Java security APIs. And the third person was doing some work on getting more embed TLS crypto libraries embedded in the C version of COSI. There were about 6 of us total spread over the different projects.
All right. So I'm Tim Terryberry from Mozilla. We had a team of about 5 people. We worked on various different experiments. So one of them is this thing called EC small mol. The idea here is that it reduces the multiplier size in the entropy coder for our video codec, which is really important for hardware since it gets you something like 40% reduction in area and a 20% reduction in latency. And in hardware, the entropy coder latency is what generally drives your clock rate for the entire video decoding process. So this translates directly to a reduction in power consumption. Unfortunately, this experiment creates some complications in software, and so we wanted to work to address those complications here at the hackathon. We worked on optimizing the software decoder. That involved 3 different patches with about 4,000 lines of code changed. And the overhead in the software decoder is now between 0.12% and 0.44%. Or in other words, negligible. So success. We also worked on this tool called perceptual vector quantization, which is something that came from the DALO video codec, which was one of the inputs to NetVC. Back in DALO, we made the assumption that you have these things called quantizers and you have these things called transform coefficients, and we assumed they were all represented with the same precision because why would you ever do anything different? Of course, now we're doing something different. So what we had been doing in the past was rescaling everything just in time before feeding it into this tool, and that was kind of suck for a bunch of technical reasons. So what we worked on here was actually plumbing through all the information on how the scaling between these 2 different things differs to the pieces that need to know about it. And if you turn off this other feature called activity masking, then everything works basically fine. We saw tiny improvement in metrics. But if you turn on that feature, then everything breaks. So this job is about half done, but that's still good progress for a weekend. And we also had some people working on what is called the constrained directional enhancement filter, which is sort of a filter that runs at the end of your decoding process and makes all your video look better. So the working group previously had 2 different proposals, one from Mozilla and one from Cisco. And recently we have merged these into a single proposal. So we're no longer competing with each other, but now that means we need to do a bunch of cleanup work to make that single proposal work well. So here at the hackathon, we had Steiner Mitskogen from Cisco, added a bunch of vector operations and neon intrinsics, and got good software speedups for all of that. So that's nice to have. And Jean-Marc from Mozilla also experimented with using a new decision metric in the encoder, which helps reduce excess blurring, which is a problem we've noticed in the new proposal that wasn't present quite as much in the old proposals. So altogether, this thing got better. We also tried some experiments with, we had a Cisco employee experimenting with some of the stuff that we had used to do in the old Mozilla proposal that the new combined proposal doesn't do. And they didn't work out so great, but it was still good to at least try those and find out whether or not they would have worked. So that's the summary of what we got done this weekend.
Do you have any comments about how it worked out to be the only person in the room with 5 remote?
Yeah, it was fine. So some of them participated from planes on their way here. But yeah, overall, I'd say it worked out relatively okay. We did coordination via IRC and that sort of thing.
Yeah. So when you look at this, are those drafts that were being implemented, or were you implementing drafts that have been working?
So what we're implementing is an implementation of the overall codec. Not all of this is in drafts yet. So for example, this stuff will get written up in drafts now that we know it's okay to proceed, right? And the same thing for this. We have drafts describing the inputs, but not the combined thing yet. Exactly.
Hello everyone. My name is Jae-hoon Jung from Sungkyuan University in South Korea. This hackathon we did proved the concept of I2NSF, the data-driven the security management. So we used the netcomp and the lastcomp with the young data model to configure security policy into the network security functions. So our result was we can provide a fast time to a market to provide the network management and operations for network security. So our work is aligned with the other IETF security working groups. So this work is done 9 graduate students at the SKKU, Sungkyuan University in South Korea. So we published the GitHub to share our code. So this figure shows the poster. So also you can see we have the client, I2NSF client based on the web to provide the high-level security policy. And also in the middle, we have the brain for security management. It is called the security controller. This guy is translate the high-level policy into low-level policy, and then provide the low-level policy to program SDN network to filter out such as the access to a firewall. For example, employee cannot access the Facebook or the YouTube during a work time. So time-dependent firewall is provided by I2NSF framework. So remotely, 6 graduate students participate in SKQ in South Korea. So I2NSF, the concept, the network security function is that the packet is comes in the infra network, and then the switch forward to the packet to network security function such as a firewall. And then if the processing for this packet is enough, just forward or drop, depending on the policy. Otherwise, it requires more investigation. It forwards the packet to another network security function, such as deep packet inspection, DPI. And then if the packet is valid, just forward to the destination host. That is the main idea of I2NSF. The goal of I2NSF project, last time IETF 97 I2NSF project case, we just using our own built application for firewall DPI. This time we used the open source, the Suricata. Suricata is originally for IDS IPS. We modified for firewall purpose this time. So we contributed this hackathon. We also proved our concept of I2NSF, also working with open source such as Suricata for firewall. Also, we enhanced our data young model, NSF facing interface, also the consumer facing interface. We modified also the enhanced for this time hackathon. Also, we showed the feasibility of our data-driven approach based on young model. So this shows the open source. So our project is the 100% based on the open source project. So we can highlight the Suricata can be used for firewall. Also, next time we are planning to use the IDS IPS using Suricata. So this is the scenario. I2NSF user specify high-level policy such as during work time, the employee cannot access the firewall. So time-dependent access can be automatically enforced by our I2NSF framework. Okay, so we already showed the proof and the validity of our interface design. Also, we showed the feasibility of our data-driven approach. So this is the GitHub source. We post the code. We can share it. Thank you for your attention. So if you have questions, please let me know. Thank you. Yeah, so we participated 4 people this time. So remotely 6 students. So we work together. Yeah. Okay.
Will those students write part of this up, and will this come to read they're working on? What is the further benefit of this to them?
So currently, we granted by Korean government for the security project. So the I2 NSF, the work chart is very synchronized for our Korean government project. So that's why we are put effort in this working group. Okay. Okay. Thank you. Yeah.
So I'm breaking up into while Max is getting his machine set up. GRASP is generic autonomic signaling protocol. It's the protocol part of what Anima is doing. Basically what we did this weekend was we tested the prototype, which has been developed in Python, on machines brought here by myself, Michael Richardson, Bill Atwood, and Jefferson Campos Mowbray, which kind of demonstrated that the code really does. Sorry about that. That the code really does work across systems. We missed another goal, which was testing against a C prototype produced by Beijing University of Post and Telecommunications, because that got held up at the check-in desk in Beijing and is not going to arrive until later tonight. Apart from that, we basically demonstrated portability, and I'm ashamed to report not one word of Python was changed during this exercise.
Okay, so as part of Anima and bootstrapping, what we need is the ability to take an individual device that doesn't know who owns it and onboard it onto a network automatically in some fashion. On the far right, what we see is the way that we're solving this is with vendor assertions, where a vendor can help that process along by either asserting actual ownership or providing a certified log service to say, I'll let you on board, I'm not checking, I'm not involved at all, but I will certify the logs so that the real owners can come and look and figure out what happened if they wish. In order for this to work, we have GRASP Discovery, which was shown to us, but we have not integrated that in. So the code that we were working with here at Hackathon was more just doing the straight TLS connections as we see on the slide. And everything was focused on the registrar, which is reading these voucher tokens and moving them around as necessary. And what we found was that while we all were able to do the right voucher formats and had done that correctly, we had some slight encodings that were different on the wrappers around those for the signatures form, and for the PKCS7 versus CMS, et cetera. And this is all just a great argument for JWS. And so we have a couple of glitches on the top level, but once you break into it, we successfully were able to pass the vouchers around and look at them. So the central components can see those vouchers and move them in all directions from each of us. That's it.
Well, there were 4 of us actively working on the GRASP demo stuff, and there were you and Michael and 3 working on your stuff. So
They're all drafts. They're all current drafts.
they're all working group drafts. Yeah.
Yes.
Hope so.
Hi, my name's Sarah Dickinson. I'm going to be presenting on what the DNS team did here today. We had a team of about 12 people, including 2 notable newcomers, Christian and Stefan, who contributed significantly to the work here today. So thank you to them for coming along. We actually worked on a number of small individual or smaller pairs or projects with 3 people on was probably the maximum for us. So it was sort of fragmented, but we got really good coverage, we felt, of a number of drafts. What's notable is that most of our projects were around DNS privacy. In a way, that's not surprising because there's so much activity in the working group and in terms of implementation and deployment of it. I'll talk through as many of these as my time allows. The first one I want to mention was led by Stefan Baltzmar. The code for it's on GitHub, and in green at the bottom are all the relevant drafts that this project was looking at. We today have around 9 experimental DNS over TLS servers deployed, mainly in Europe, but also some in North America. Note the word experimental there. We've had a few hiccups with them. So something we've been talking about doing for a really long time, but we actually came along this weekend and we did, was we wrote monitoring software so we can actually look at these servers out in the field. So it was based on an Nagios API. It checks the server is actually responding, doing DNS over TLS on port 853, that you can authenticate it based on the profiles draft, which specifies how that should be done for DNS. It also checks if the certificate is about to expire and flags that up. One of the key things this does is it gives us a platform to add additional tests in to see if these servers are implementing other privacy-related specs, like key name minimization and like keep alive. So what we want to have is a dashboard of these experimental servers and all their capabilities with regard to all the standards that are out there. This is a screen grab of a private, I never know how to pronounce it, in Kaga, front end using this plugin. So as you can see, many of our servers need their certs renewed very soon, but are working fine otherwise. But now we have this plugin, it should be straightforward to fire up other monitoring systems to look at these, and they'll be public. Okay, so the second thing that was worked on related to this was by Christian Hoytmeyer. Again, the code for this is on GitHub. Is that we actually want to start looking in detail at what performance we get from these experimental servers. So a test script was completed that fires off several queries over a connection to one of these servers and looked at the RTTs. This was really interesting because what we saw in the numbers was not what we expected. We were expecting to see a really slow first query and then pretty flat performance. That isn't what we saw at all. So this has given us a lot of food for thought, and this is definitely data we need to go looking into so that we can get a firmer grip on what the performance of these deployments is and what's possibly causing these strange numbers. The other area we worked on was DNS padding. So there are mechanisms defined in standards that tell us how to pad DNS queries in order to defeat traffic analysis, because the size of the query can actually give quite a lot away. What we haven't known until lately is exactly what policy to use to do the padding. In the last few months, DKG has done some really good research in combination with Alexander Marhoff, who's got a draft out, to figure out what the right policy should be. We didn't have any implementations of that policy that came out of that work until today, but DKG spent this weekend implementing it in libnot. So the command line tool kdig now uses this default policy, and KRESD also uses this as well. And the plans are also to put this in getDNS and Unbound. So as a result, we'll have a nice standardized picture of how to do padding policies in DNS. Similarly, Andre Soure has also been working on more new implementations. In terms of client-side DNS, we've added a new forwarder implemented in KRESD that will let clients from their own machine actually use these servers that are out there. And I'll leave it there. Thank you for your time. There was one key one on a DNSSEC key rollover related one. So Willem Torup was starting work implementing in getDNS on a dynamic management of the root key rather than relying on 5011. So that was our one other project. Great.
There we go. Maybe. Changed something. Ah. There. All right.
Yeah. Okay. Hi, we worked on AMT this weekend. And so AMT does tunneling of multicast traffic over unicast. And we're really excited about the possibilities. So at Akamai, we're planning on, this didn't come out very well, on deploying a video service that uses this technology. And we would, we think it can make the internet a great deal more efficient. You want to know more about it, come talk to me. In lab today, in lab this weekend, we had sort of a miniature multicast enabled ISP in, it's why I had so much equipment over there. It's mostly running on a couple of virtual routers, the Cisco CSRs, in the desktop. And we connected several devices to them and we're running multicast over them. We had our friends from BBC also are looking into some multicast video systems that are going to consider using similar technology. And they were testing their video implementation on our network and sort of working out some of the kinks and seeing how we can use AMT together. Anything else? The multicast sender and the distribution network essentially are the parts that were there, and it was going out to the internet to get the content coming in from their head end. So this weekend we ended up, I ended up spending most of the time porting AMT relay to OpenWRT. This was took a little longer than I had hoped, but this is one of the gaps that's missing, where when there's a non-multicast enabled Wi-Fi network, then having an AMT client embedded in the receiver is the way that we have, I think, 3 different implementations of such a thing so far, and having a relay located in the home. For a lot of networks, the pain point is the access network into the home. So having, sort of doing a proof of concept that this can be deployed on the devices distributed in the home mean that they can join the multicast streams into a multicast capable network and share that, that prime time viewing traffic possibly is the hope and intent. And so getting that into a home Wi-Fi device was to me one of the critical pieces. We encountered some bug fixes and cleanup, and I also put up a description of what we did in our how I was running the test bed and how to set up an equivalent system. We ran several experiments with video and some pieces on the infrastructure that we had here. And I want to say thank you to Lucas for coming and participating, to Kadar and Velvendran, who I had never met. I looked him up. He hasn't participated in IETF before, so I'm not sure he's even a first timer, but he did, and I hope I haven't butchered his name too badly, but he was remotely located in, I think, Mauritius. Just kind of, we were talking over Jabber to communicate, and he helped me get over the hump on some of the installation problems with OpenWRT. So score 1 for the outreach that IETF gave us. And I also want to thank the prior work done by on this previous implementations. Thank you. Questions? Yeah, RFC 7450 is the AMT specification, and that's a proposed standard specification. There's implementations in Juniper and Cisco routers already, and then this is sort of an external open source implementation that the MOD working group put together that we've been expanding on. That's going to fit our deployment model a little better for Akamai. I think a lot of people will be able to use the Cisco and Juniper versions. MOD. Total would be the three of us, right? I mean, there was Kadaran and myself and Lucas.
Okay, SCTP model and all that. Next. After that, we have the LoRaWAN Wireshark dissector. So you guys can do that.
Yes.
Hello. We've been working on distributing simulation runs in OMNET INET, especially the SCDP model. And a brief introduction: SCDP, Stream Control Transmission Protocol, message-oriented, and it's used for the WebRTC data channels, for example. And the OMNET simulation framework is a discrete event simulator, and we are using the INET model where the SCDP model is implemented, as well as IP, Ethernet, TCP, and so on. And running large distributed parameter studies is often limited by the CPU. So distributing them, it offers a great benefit in kind of speed. And so we built a Python toolchain, and this Python toolchain covers job dispatch, and it has a small code base of about 3,000 lines of code. And we are using it in our test bed in our laboratory in Münster, University of Applied Science in Münster, Germany. And we have 20 machines running FreeBSD, and they are booted by Pixie boot. And they have a common NFS share. And we tested our toolchain. And the results are 20 machines are 20 times faster. The results are collected automatically and analyzed automatically. And this is a great improvement for our measurement and simulation toolchain. Thank you. Sorry? No. Yeah, we built the setup of the machines has been done before, so they've already been booted by Pixie boot. We improved the tool chain or built the tool chain and tested the tool chain, ran some experiments, and yeah, improved the collection of data. 3.
Yes. Great. Good afternoon. LoRaWAN is one of the link layer technologies that the new working group LP1 is interested in. This is a very constrained radio transmission technology with payloads that are just a few dozen bytes and extremely slow transmission, extremely constrained, even more constrained than what 6LoWPAN and 6Low were interested in. So this justified the creation of a new working group. So our purpose, those kind of technologies are very much treated as vertical silos so far, with dedicated tools, dedicated management systems. And so we believe in this working group that we can bring this technology into the IP internet realm by clever techniques. And so what we want to do is check live LoRaWAN traffic and decapsulate the protocols that we intend to carry into those payloads, which right now is barely application sitting on top of Mac. So what we achieved this weekend is, first of all, the source code is available on GitHub. There were 5 of us and 2 students among the 5, one attending remotely, one present here. Those 2 students were first-time IETF attendees, and we brought everybody up to speed regarding writing Wireshark dissectors, which none of us was an expert before. And we captured traces remotely from France using one of those devices that sits on my desk at my office in France, running on the Orange commercial network. And we managed to dissect all LoRaWAN frame headers, all the back command codes, all the stuff, the network telling the device to change frequency, change modulation, etc., etc. So that's what we achieved, and what's left for future work is to fully dissect all the commands, not just command codes, but all the options, all the parameters, and also we have large stuff to address, which is all the crypto stuff. Validate the MIC message integrity code, decrypt the payloads, and we're not expert in this way of using Wireshark dissectors, so advice would be appreciated. How we convey the keys, the session keys to the dissector, etc. So we'll be working on that later. And eventually what we want to do is be able to decode the full IPv6 over LoRaWAN stack that we are developing at the LP1 working group. And hopefully by next meeting in Prague, we'll have the dissector for that. So all the missing shim layers between IPv6 and down to LoRaWAN. And in Prague, we intend to bring those kind of devices and have our own network running in the room as opposed to capturing remote data. And I think that's it. No question? Okay.
This is my laptop. Could you? Thanks. I don't know what I'm doing. Oh. I'm gonna put this up there. Ah, that was easy. I'll just close this thing. I have it full screen. That's the problem. No. Come on. Let me just write it this way. All right. Sorry for that, everyone. All right, so we worked on Captive Portal interactions this weekend. So what's the problem? Captive portals suck. Everyone tries to log into them, and then they give you different look and feel. Sometimes they don't work. Sometimes they kill your VPN or your HTTPS session. Man in the middle is all that fun stuff. So the Captive Portal working group's trying to improve that interaction, make it so it just works nicely with all devices. So during this hackathon, we tried to implement a bunch of drafts related to that. Some of them are expired, some of them are in the works right now. Yeah, so that's what we were doing. So to get there, we put together an architecture ahead of the meeting to sort of try and call out exactly how end user devices would interact with the captive portal. And then we tried to adhere to that architecture during the hackathon. We communicated over email ahead of time, and then during the hackathon, we used Slack to coordinate with each other, as well as just communicate over the table. So we worked with a bunch of technologies. So all the, a bunch of different RFCs here, drafts, one RFC, an open source implementation of a captive portal, Wireshark, TCP dump, a whole bunch of things. So what we actually did is pretty much from the ground up, we made it so that a VM on my laptop could automatically log into the captive portal without any user interaction. It would just detect there was a captive portal and log in for us. So it was pretty good. It worked out pretty well. During that time, we also extended TCP dump to support some of the new ICMP messages that we were using as part of the architecture. And we did the same for Wireshark. And throughout it all, we got a bunch of feedback to the working group because just a lot of stuff that was unknown needs a bit more fleshing out. So we're going to give that feedback on Tuesday. So how does it work? Kua Chili is the captive portal. The user device logs in to the network, gets a DHCP message. Ideally, that DHCP message will tell you what the URI of an API server that the end user device can communicate with. You'll try to communicate out to the internet, maybe an HTTPS session. That will be blocked, and the captive portal will send an ICMP message saying that it was blocked because you're behind a captive portal. The user equipment detects this ICMP message and actually invokes some sort of automatic behavior to deal with the fact that there's a captive portal. So in my case, I had ICMPD running, sniffing a raw socket for ICMP messages. When it detected one of these, it would invoke a Python script that would talk to the API server to find out what it needed to do to log in, and then actually post its credentials to the server, which would then cause it to go to the captive portal and say, hey, this guy, let him through. And then all the further requests would actually be allowed through the captive portal, and you could talk to the internet as normal. Finally, if say you're about to run low on quota, or you've exceeded some sort of bandwidth requirements, the captive portal server would send another ICMP message indicating that this was happening. And we haven't really done anything with that yet, but ideally, you would display something cool to the user saying that you're out of quota. So it's all up on GitHub or various other open source stuff. Everything we did is on there. Who did it? So there was a bunch of us, 7, 4 of us here, 3 of us remote, a collection of different companies. So it was neat to work with a bunch of people from different backgrounds. So as I said, lots of discussion during the presentation, and it worked. So I think it worked out pretty well. Any questions? There's probably, I would say there's maybe some debate as to exactly, and the drafts are very recent, so they're fairly poorly defined or stuff still out in the open. So I'd say there's some competing interpretations of them. There is another competing draft maybe to the DHCP RFC that we wanted to implement, but we didn't get around to testing that one out. It was in user space, so I used the just a raw socket. Yep.
All right, yeah, so I'm representing the TLS team. So we got a pretty big group together here, and we've got 4 minutes, but I'm just going to go over these 5 points real quick. Who was on the team, what we worked on, and that's basically it. So this is a large group of people, somewhere between a dozen and dozen and a half, and folks were represented from a bunch of different places. This looks like it might have made a change to the slide ahead here, but from different websites as well as browsers, as well as we had people from other various places from Cisco. We had people who were first-timers at the hackathon, as well as first-timers at IETF altogether, and remote participants, including somebody on a plane coming in, as well as somebody in Japan. So this is a good large group. We coordinated with Slack, and I think it worked out pretty well. But we worked on a bunch of different projects. The sort of most notable one is TLS 1.3. As people following the working group may know, this is in working group last call. Draft 18 is sort of the second to last draft. The last one with any substantial changes is draft 19. And draft 18 is currently implemented and used in the wild by browsers, including and websites, including Gmail, at almost all sites that use Cloudflare. Facebook has an experimental site that uses it. TLS 1.3 and 0RTT with draft 18 work on these. So this is great. Draft 19 is supposed to be the wire format final version. OpenSSL supports this. And a part of this hackathon was to try to move some of the implementations up to the very last draft 19. And results, Boring SSL team got 0RTT, working with TLS 1.3 on the server side, as well as updated the 1RTT. NSS, that powers Firefox, also is getting pretty close to draft 19. There's a Haskell version that's draft 19 as well. Fizz, which is Facebook's implementation, is pretty close to draft 19. Pico TLS also, you can see updated key schedule. That's sort of the major change between draft 18 and 19. And most of these implementations are almost all the way there. So aside from TLS 1.3, there's a bunch of other smaller projects that we did, or maybe not smaller, some of them were big, one of which was in the DTLS space, and Hannes and Thomas worked on this. Basically, there's a problem with DTLS if you have a sort of embedded devices behind a NAT. If the embedded device goes to sleep and the NAT loses the connection ID, then when you wake back up and try to connect to the server, there's no way to actually punch through that NAT except if the NAT has actually forgotten the reverse translation path. So the proposal here that they implemented was to add a new record ID, a connection ID field. And this actually turned out to be slightly more difficult than was originally expected. But by the end of the second day, this was mostly implemented. So DTLS, there's demultiplexing now inside the protocol with this draft right here. We also worked on other extension proposals to help the working group in various ways. The first of which was certificate compression, which was worked on by Alessandro. This is a way to, in the TLS handshake, shrink down the size of the server message by compressing the handshake. And this worked out. Boring SSL is an implementation. Another big proposal is delegated credentials. If you're going to the TLS working group this week, you'll see a small presentation by Sabot about this. It essentially allows servers to use short-lived keys. Oh, I'm running out of time. All right, so we had 3 implementations interop with this, which is very promising for that. Other work, Pierre worked on the ability to have certificates that can work with IP prefixes. This is useful for these 2 proposals right here that are listed. So as an overview, these are the sort of things we achieved as a team. Thank you.
All right, so Yang, NetConf, and ResConf. So we have no slides. We prefer to spend time coding and doing a demo. So yeah, so table of a couple of people there, but some more remotely, maybe more than 10, not all full time. So we worked on NetConf-based notification implementation and interrupt testing. Also, we worked on a lot of tools. In NetConf, right now, we're doing a way to migrate the way we're doing Yang models, and we've got a way directly with Rob to go from one model type to the other model type. Then also, we spent quite some time on what's called this Yang catalog, which is an inventory of all the Yang models. So very pleased to have someone from BBF there. So we spent quite some time looking at all the modules there, making sure they compile. We found bugs in some validators. Most of them are fixed already. We wrote a script to put all these Yang models extracted from IETF Yang IETF draft directly into GitHub as a cron job. In the validation, we've been adding plugins for different SDOs, IEEE, MEF, BBF. We found some issues in the document in NetConf NetMod on the revision. I'll skip the detail. It's in discussion right now in NetMod. And this Yang catalog, the inventory and the population, we've been populating this, and then I'll pass it to Joe Clark. So basically inventory, validation, and then search, maturity, etc.
Thanks, Benoit. So last time in the hackathon in '97, we presented this tool that does searching. So the idea is to help out Yang model developers find out what's available and help them get an understanding of what impact their modules have, help working groups get an idea of where they might have stoppages or they have bottlenecks in terms of getting drafts progressed to RFC, to proposed standard, or to a final state. So just setting context for those who haven't seen it, this is the Yang search tool. It's in GitHub. You can search for various things using keywords, regular expressions. You can get results. So that's the tool. What we wanted to do this time was we've done a lot with the IETF, and as Benoit said, we want to bring in a lot of other SDOs. And since we had participation from the Broadband Forum, we decided to We decided to add BBF as a quote-unquote first-class citizen. What you're looking at here, pardon the color, wow, that really did get washed out. What you're looking at here is an impact analysis showing what modules are impacted by and what are impacting. In fact, Kent Watson walked up to me as I was coding some of this and said, hey, what kind of impact does this module have that's being currently worked on in NetMod? And what you can get, I'll try to zoom in a little bit, what you can get is that there are some standards from the IETF interoperating with standards from BBF, and we can get an idea of, via what is highlighted in black, what might be showstoppers or what might be bottlenecks in that process. We also incorporated the ability to link out to BBF, for the BBF standards, to link out to their documents, so we can pull that up, look at their documents, as well as IETF standards and drafts. And finally, we're incorporating more metadata into what we have in the tool to be able to show, to be able to really dissect and really get intimate with what modules have and how their structure is built. And we want to add more capabilities into that to launch tools like the Yang Explorer and to be able to offer downloads directly from here, as well as integration with the Yang development kit.
And one more thing I forgot to mention is that if you work with NetConf, get a hello message, and we got a script to get all the Yang models and deviation capabilities as input to put in this Yang database search as the next step.
There's a question? So the question is how to import a Yang module into this. This currently pulls automatically from the public Yang GitHub repository, and I believe the way to get into that is to just issue a pull request to the Yang repository. Though I'd be happy to add modules if you have other
areas, other places where you have modules, I'd be happy to add them as well.
There's a REST API also.
Yep. And there's a REST API to the main Yang catalog as well. The database is dynamically regenerated based on updates to currently IETF and now BBF modules.
But we have REST API to also, if you want to add your module directly to that. Yes.
For my work, all the BBF integrations, were added this weekend.
So the script for GitHub done this weekend, all the bugs fixing done this weekend, the plugins done this weekend, the interrupt testing this weekend.
Thanks.
Okay, well, thank you to all of you for your presentations. Whoops, sorry about that. And appreciate your, the timekeeping. I know it was particularly challenging for the large teams where you had many different projects. But, it's, we want to make good use of time, and we also want to hear what you guys did. So hopefully we found a good balance. And every project that I heard presented today hit very well on one, if not both of these. Certainly, we're all advancing the work of the IETF. That's one of the criteria they'll be judging on. And then also we had a lot of new folks, either new to the IETF, new to the hackathon, come in. And those of you who have been doing this kind of stuff for a while, I really appreciate your taking the time to help bring new people in. And I think this is a great way for people to come in and very quickly become productive and start contributing. So it was great to see that happening. So the hackathon photo contest, I've seen several of you have been posting things, and we have a couple different winners that are very different from each other for different reasons. So we're going to give out 2 prizes this time. And I haven't set up the prize table yet, but I'll do that before they announce the winners. And so that's not one of them. That was mine. Jaime Jimenez, am I pronouncing your name right? And are you here, or did you just roam by and take the photo? Okay, he was here, yeah. I don't see him here right now. Okay, I'll find him. And the other one, Yari, even though he's a judge, he's still able to win this one. I thought it was kind of artsy and captured what was going on at that back table pretty well. So so we have 2 winners, and they'll get first shot at some of the prizes, and the rest of you will get shots. We don't have any super fancy prizes. We never do, but hopefully stuff that you at least find fun and a little something to go away with. One of the benefits I mentioned at the beginning, which I want to remind you of, is the opportunity to present what you did at Bits and Bytes. And I know a lot of you had a demo or thought of doing a demo, but then really didn't have enough time perhaps, or didn't get it working. If you're interested in doing something at Bits and Bytes, let me know. Right after I finish talking here, or sometime before we leave at 4 would be a good time to let me know. If you don't get a chance of telling me now, you can send me an email. Hopefully we'll have room to accommodate everyone, and we'll do our best to do that. There is the ability for some of you who had like an application that you might want to try to make live. The guys from Comcast are pretty keen on having people tap into their network that they're bringing into the Bits and Bytes room. So, maybe your app could show up on your neighbor's television screen or something if they're a Comcast subscriber. But yeah, this is a great opportunity, I think, and either show off what you did or go by and see what other people did at Bits and Bytes on Thursday. As I mentioned before too, we will have the hackathon little corner in the lounge, and we'll take our signage down there, and that'll be a place where if you guys want to work on your projects for Bits and Bytes or just keep doing working on what you worked on in these last couple of days. That's there for you to do that. And again, a big, huge thanks to our sponsors. We wouldn't have been here. We certainly wouldn't have had food, T-shirts, and not any prizes if it wasn't for our sponsors. So again, to Ericsson and Mozilla for helping us out there. And Ecker, if you don't mind coming up, you're here from Mozilla. Big thanks to Ecker and Mozilla, but he was instrumental in getting their sponsorships.
Yeah. Well, thanks everybody for coming. We've been doing this ever since. No, I have no slides. We've been coming pretty much since the beginning, and these seem like a really great opportunity. It's super hard to deploy protocols in a vacuum. Like you write the thing in the document, and then the document's like full of errors until you try to implement it. And so this is a really great opportunity as a focusing exercise for us to sit down and actually try to, force you to try to implement and have high bandwidth communications so you can get interrupt. And so like when we have problems, you just yell over and I say, hey, what are you seeing? And we try to figure it out. So that's really great. It's been an opportunity to build a community that survives the hackathon. When we first did this, Nick started it out for TLS, and he made a Slack, and we're like constantly on that trying to coordinate TLS 1.3. That's been really great. So first, thanks to the TLS team for working with me on this, and also thanks to everybody here for coming. I think it's a real step forward in terms of our ability to deploy protocols that will work as fast as possible. Thank you.
Okay, and Yari helped a lot with getting Ericsson sponsorship, but he's busy being a judge and winning the photo contest and being IETF chair, and so but Gonzalo, if he's available, we're gonna, he helps a lot with Ericsson sponsorship, both sponsoring the meeting and this hackathon, and when he frees up, we'll give him a chance, maybe not right now if he doesn't make it, but to talk to, and we really owe a big thanks to them. And the rest of you, I'd appreciate it if you kind of circulate the fact that, hey, we're looking for sponsors for future hackathons to continue to make this happen. And I certainly appreciate all the effort you guys put into it. This obviously wouldn't happen at all if you guys aren't here. You know the way it works. You volunteer to lead the projects. You help new people come in, and so that's really critical. And I hope you continue to support the hackathon with your presence and your work in Prague and Singapore, and hopefully we get to just keep going. So the judges are trying to figure out how to award prizes, or awards, which is always tough. If you can just hang out, I think maybe within 10 minutes or so we should have that. Shouldn't take too long. I'm going to get the prizes and swag that we have, and the way it's going to work is they're going to announce some winners. Winners get, as in the order they're announced, get first shot at any stuff we have, but and we're just going to keep going through until we run out of stuff. So at the end there might be some things, and you guys can have a look at it as well. Google has donated some stuff that we can give out, so thanks to them for that. The IETF Secretariat came up with some stuff, and so we'll be giving that out as well. So I'm going to go get that set up. They're going to finish their stuff, just hang out a few minutes, and we'll move right along. No, it's basically
You don't ordinarily. You must have played more really. Oh. Right, you never come back. No, yes, yes. Yeah, we yeah, that's all we, so, you know, I can buy this. That's why we like so I think it's very yeah, I did want to say like the fact that you set this up as a huge I'm just not, I never know how to feel. Like I thought this was Michigan, you don't have part of Michigan, right? Yes, HR, yes. Yeah, the funny is like, it's not like, not on the so we'll insist that they you know, we're people who present. Yeah, no, that was by setting up the thing. And then, yeah, it's kind of what we do is just take the but then what we do, we realize the faults. No, but like,
Okay, the results are in. The judges have deliberated. It was a tough thing to do. The decisions of the judges are entirely final and whimsical. And the prizes are absolutely magnificent over there. We have water bottles, we have notepads, we have Google Pens. Be impressed. Now, and we have a few extra t-shirts if you are very small. No? Oh, these are different. Okay, I thought these were the Hackathon t-shirts. Okay. So, I said this was tough. This really was tough because we have a bunch of projects who come every time and do a lot of work, and we have a bunch of new projects that have come and really kicked things off. And it was really tough to figure out who to throw the best overall at, because the best overall gets to pick the water bottles. The rest of you get stuck with the notepads and the Google Pens. So the best overall goes to DTLS, TLS, DTLS. So go up and collect your stuff. And as I said, it was really a tough decision to come to. It was a close one. So if you think you were best, keep thinking that. You're probably right too. And while they're collecting that, I'll go on with the next one. We tried to figure out for a little bit what to call this one, but Ro Pelletier came up with the right answer to this. It's the Measure Twice, Cut Once prize. And that goes to the NetVC people because they were testing technology before it went into the document. And that's cool. We like that. So NetVC people, go get yours. And we have photo ops up here when you're done collecting your stuff. You even get to have the new IETF chair be in your picture, which is really cool. Sorry, taking your picture, yes. And by NetVC people, I meant NetVC person because the rest of them were remote. But we have more on the remote stuff later. We also, okay, the next one is the captive portal people for kickstarting a working group that hasn't really been able to get traction yet. And I think I'm really glad you guys came here and started working on the technology and did a kickoff. And I hope that propels the working group into great things. So captive portals. Get your Google Pens. And we need some effigies for the remote participants with you. WebRTC gets mentioned for best use of students. This was really close with the I2NSF group. But we figured we gave the I2NSF group that last time. And we hope you guys keep coming back because getting students involved in this is really important. So WebRTC, thanks for bringing students into this. Pick up your prizes. And then we have the LoRaWAN people for newcomer. Get your stuff. And then the most whimsical of all, we were debating any other things, and we figured
the AMT group has to get the prize for the most remote participant. We actually checked that, and it turns out Mauritius is a lot farther than Korea. So you get the most remote participant. If there's anything left, pick it up. And after they're done, locusts can go to the table and start eating all the remaining plants there. Anything else?
We should just mention the present. So we also wanted to just mention that
yes.
the judges wanted to make one comment. We wanted to compliment the DNS team on their presentation because they just very nicely said, here's what we're doing, here's what we're going to, here's what we accomplished, here's who did it, and here's what the drafts, the way they did it. So thank you for taking the time to help us clearly understand what was there. So we just encourage people to think about that. And the other thing was to think about help those of us who may not understand what you're doing, explain it quickly in the sense of what change are you making on some of this?
Yes, as we're up there as judges, it's sometimes difficult to figure out what's background information and what's telling us what happened this weekend. And the DNS presentation was the most helpful for us in figuring that out. And then finally, I wanted to, where did Charles is behind me. Charles, yes. Thank you for continuing to chair this, and I'm done.
All right, well, thanks again, and congratulations to all the winners. I thought we weren't going to have anything to give out. We actually have tons of stuff to give out, so please help yourself. You're free to take more than one thing even at this point, or those of you who haven't had a shot at the table, maybe go and take a look at that. But yeah, thanks again for participating in the hackathon. Couple things that I wanted to share with you. And don't run off because we have a few more things we want to cover after the prizes. But while it's still fresh in your head, I've already had some good feedback as to things we could do to make it better next time. Either catch me or send an email to me while those thoughts are fresh in your head. I don't mind hearing the bad things. I like to hear those because that's the only way we're going to make it better next time. So appreciate that feedback. I also posted a link where we're getting all the great pictures that Richard's taking, or at least the sampling of some of the best ones available. And he's very generously said we can use them for our own purposes so long as you mention it in the context of the hackathon. You can use those photos. If you want to put them out on social media or whatever, just make sure you mention the hackathon and then it's all good. He does fantastic work, and I think we want to get the word out, and his photos will help with that. So the link, I sent an email, plus I put it in the portal. And I mentioned Yari before, who's been a big supporter of the hackathon, and Alyssa Cooper, our incoming IETF chair. She's also a huge supporter, and I'd like to invite her up now to say a few words. And while you guys are looking over prizes, I ask you to kind of keep it down because I'd sure like to be able to hear what she has to say. So Alyssa, come on up.
Thanks, Charles, and really huge thanks to all of you for making this event successful time and time again. As Charles said, we're always trying to improve it, so please, if you have any ideas about how to make it better, ways that we can expand, or other things we should be thinking about to better integrate running code into the IETF process, you can talk to him, talk to me, but we really appreciate all the work that you've put in. And as he mentioned at the beginning, the lounge is going to be open all week, so if you want to keep up the work with your team or with other people, we would love that. This is really a very important part of the lifeblood of the IETF, and keeping us on the cutting edge. So thank you for doing all that you're doing. Huge thanks to our sponsors. I know they've been thanked a few times, but I didn't get to thank them yet. So thank you to Ericsson, Mozilla, and Cisco DevNet. The event does not happen without a sponsorship. So if you have even the faintest idea that your employer or somebody else's employer might be interested in sponsoring the hackathons in the future, please come talk to me or to Charles or any of the folks who have been involved. And lastly, thank you to the judges for putting in all the time to evaluate the presentations. I know we didn't exactly have the same type of prizes that we've had in the past, But hopefully people feel like their work has been appreciated. So thanks a lot, and we'll see you at the rest of the meeting this week.